Hi there, folks. Today we're looking at points, lines, and planes, all right? And points, lines, and planes, these are the three undefined terms of geometry. Not in the sense you're going to look at this and go, wait, you just gave me a definition of this. Not in the sense that we can't do a written description of it, but you'll see what I mean as we look at the definition. So the three undefined terms of geometry, point indicates a location and it has no size, all right? So if we're thinking about an actual point, you can't draw a real point because it has no size. It has no thickness in any direction, all right? So when we draw it with some size. We draw it with some shape, all right? We draw it like this, all right? In all honesty, that is multiple points kind of strung together there as they start to form this thing. So we have to draw it in some way, all right? So we draw it like a little dot, but in reality, it has no thickness. It's so precise and small that it has no thickness in any direction, all right? For geometry purposes, we always label points with capital letters. So I'm going to call this point A, right? Piece of cake, all right? The next one is a line. A line is a straight path that extends in opposite directions without end. And once again, it has no thickness. So technically, we can't draw an actual line. When we draw it, our line has some thickness because of the thickness of our pen or pencil, or in my case, this marker feature on my computer, all right? But when we draw this thing, kind of looks like this, all right? It's straight path, but in reality, it doesn't have the thickness that I've drawn it with, all right? There's a couple ways that we can label lines. We can label them using points. So if I have a point A and a point B on this line, I can call this line AB, and I do that by writing AB, and then I draw a little line above them. Amazing, right? The symbol for line is a little line. Crazy. Okay. The other way that we can write or label a line is using a single letter, and typically we use a lowercase letter written in cursive. One of the ones that comes up a lot is L. All right. So if you just have somewhere floating near a line like a lowercase cursive L, we can just refer to this as line L. All right. And sometimes that can be a little bit confusing only because maybe some of us don't remember all of our cursive letters. And also some of us have a little trouble drawing those, that kind of thing. If you just say line L and you don't have the L drawn in cursive, I'm not going to, blow a gasket or anything. So just keep that in mind. Most students find that they prefer to always use the point labeling system because it kind of is universal and works for everything. Point A, line AB. All right. Next, we have a plane. This is the third undefined term of geometry. And again, it's a flat surface that extends without end and has no thickness. So now we're talking about like a piece of paper that keeps going forever. That is a plane, but it has no thickness. When we draw it as having thickness. All right. And really, like my note screen is a plane, but when we try to draw a plane on our paper, again, that can be a little bit weird. We kind of usually draw it like this. We draw it kind of like this as like a visual representation. Almost imagine that is coming off the page. Imagine it as a three-dimensional shape sticking out from the page. But again, it has no thickness. And there's a couple ways we label this. If I were to slap a few points on here, I'll call this point A, point B, and point C. We can call this plane ABC. All right, is one way to label that. Okay, and so we still use that point system. All right, we don't use a symbol for plane. Usually we just literally say plane ABC. But again, it's all very simple and logical. The other way that we might have a plane kind of described, if you see a capital letter floating off in the corner of a plane, I'll put a Q there. All right, but there's no point listed. That is not labeling a point. That's labeling the entire plane. So we would just say this is plane Q, okay? So sometimes we'll use that same designation of just one single capital letter, and the only way to tell the difference between a point as a capital letter and a plane as a capital letter is look for a point that's near that letter, okay? Again, if you're looking at this going, it would be a whole lot simpler if I just use the same notation every time and always use the points to label things, you're absolutely right. That is a simpler way to do it. In terms of remembering things, but then you have to write just a little bit more. You got to write 3 letters instead of 1 letter, okay? So that's the 3 undefined terms of geometry, All right. Couple definitions to go along with those things because, we already have a concept of points from algebra and lines from algebra. Even planes, we have a concept from algebra. Remember the Cartesian coordinate plane, all right, was our XY coordinate plane where we would graph things, all right? That was a plane. All right. It was a flat surface that continued forever in each direction. We usually didn't draw all of the numbers, but we want to investigate different things, different aspects of points, lines, and planes. So collinear points, all right? So this is a designation to points that are all on the same line. All right. So if the points all exist on the same line, we call them collinear. They share the same line. All right. Coplanar points, just like collinear, they share the same line. Coplanar, the points share the same plane. So if all the points are on the same plane, we call them coplanar. All right. They share that plane. All right. For example, if we kind of look at this diagram, and again, when you see that plane, the way it's drawn, we're kind of drawing this almost like a three-dimensional shape when we see that line going up and down. And you notice the dotted line, how when it touches at point Q, we have this dotted line. That means that that line is going up and down. It's going down through the plane. Almost like if I took a pencil and poked it through a piece of paper, all right, we can imagine that line that has T and Q and N on it. That's like a pencil being poked through the piece of paper, that green sheet of paper, all right? That's how we visualize things in 3 dimensions. We use things like dotted line. Dotted line means that that thing is behind the other guy, okay? And actually, when we get down to here, we could have made it a solid line, you know what I mean? Because it's no longer behind that thing, okay? But those are the subtleties you'll see in the pictures that we use in geometry. So it says name line QT in 2 other ways. So if we see line QT is the one I've just been describing, and that's the line that's going up and down, remember, I can use any of the points, any of the 2 points on the line. So instead of using line QT, I can say, hey, this is line QN. And that would be the same line because it goes through those 2 points and it keeps going. So yeah, it eventually hit T also, okay? Or we could just say, hey, that's line M. And again, that's not a true cursive M, but we'll make it a little fancy, And again, that's not a true cursive M, but if we want to write it like that, that's going to be fine, okay? As long as we understand what that means. And of course, I could have done something like line NT, or line TN, or line NQ, all right? So as long as I use any 2 points on the line, and the order of those 2 points doesn't matter when we're talking about a line. So there's lots of ways to label that one line, okay? Name plane P in 2 other ways. So plane P is that green shaded area. See, P is the designation when we're using the single letter. So I could use it. I could use points to label this thing. And again, I pick any 3 points on here. So I'll just look for 3 points on there. Oh, how about V, R, and S? There we go, plane VRS. Or I could choose other points. I could say plane, let me make sure I get Q in the mix this time. I could say plane QSV. And again, there's lots of ways to do that. The only ones I can't use are points R, Q, and S together. All right. R, Q, and S would not label this plane. All right. And we'll get to this a little bit later when we start talking about postulates. But I can't use those because they're collinear. And if you think about it, how many flat surfaces could go through that line? See, I could start rotating and have other flat surfaces. So because it's not specific enough, because there's other planes that goes through those 3 points, I can't use that as my label for this plane, okay? So the only rule when we're labeling the plane using 3 points is make sure they're points that aren't in a line, okay? Next one, name 3 collinear points. So 3 collinear points, we were just talking about 3 of them. R, Q, and S are all collinear. They all fall on the same line. Or we could also do T, Q, and N. Okay, those would also be collinear. They're all on the same line. I couldn't do N, Q, and S. There's no line that would go through all 3 of those. Okay? And then it says name 4 points that are coplanar. So if we're looking for coplanar points, I need 4 of them. The easiest ones to identify are R, Q, S, and V. All right. And again, R, Q, and S, I can't use that to label the plane, but they're still all coplanar. They're still on the same plane. Okay. Let's talk about a segment. A segment is basically a part of a line. All right. If I were to basically cut the ends off of the line, instead of having it go forever in each direction, I would cut each end off so that it stops in each direction. Okay. So a segment is part of a line that consists of two endpoints and all the points in between. All right. So again, it's a line that we cut the ends off of it so it doesn't keep going forever. It stops on each end. All right. We label the line and a line segment similar to the way we label a line. So here's A and B using those 2 points, and those are the endpoints. That's where it stops, okay? And when I label a segment, I want to use the endpoint. So even if there's another point in here, like C, if I want that whole line segment, I would say that that is segment AB. And the symbol for segment is a little line segment above it. Oh boy, right? So instead of having arrows on each end to indicate a line, I use a line segment as the symbol for line segment, okay? It's all very simple and logical if you think about it for a second, okay? But that's how we distinguish between line AB and segment AB, is the little symbol that we put above them. So that symbol becomes very important. Even though it seems small and insignificant, it's very important, okay? And I have other segments here, like if I wanted to go just from here to here, from B to C, that's still a line segment, CB, but it wouldn't keep going towards A, all right? It stops at C and it stops at B. And again, I can mix up the order. I could say BA or AB. I could say CB or BC, all right? I also have line segment AC in there, okay? A ray is basically a line that's been cut in half, all right? And that's a strange concept because lines go forever. How do you know where halfway is? But just think about it visually. If I were to cut a line anywhere and get rid of part of it, all right? So there's an end point on one end, so it stops on one end but goes forever on the other end, okay? That's a ray. So part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. So again, it looks like this, where we have one point and then it goes forever in one direction. So instead of continuing, so it's kind of like a cross between a segment and a line. It's kind of a mix between the two, if you will, all right? A line goes forever in each direction, a segment ends on each end. Well, a ray ends on one end, but it goes forever on the other end, okay? And again, we label this kind of like this. So here's A, and let's say point B is somewhere on here. To label this as ray AB, I say AB, and then I use the symbol of like a little ray above this thing. See the little arrow? And this one is different from the rest in that you can't mix up the order. When you see this, AB, that symbol above it has a ray that's pointing towards the right. The reason it's pointing towards the right is because that's the direction the ray goes on the actual picture. It starts at A and it goes towards B. I cannot say BA and draw the ray symbol this way because that's indicating that it stops at B and it goes forever towards A, and that's not what I have here, okay? So make sure that with rays, you're being very meticulous about the order that you write those things, okay? Opposite rays are basically rays that share one of their endpoints, but they form a line when we put them together. So they're kind of rays that go in opposite directions. So again, if we look at something like a line, there we go, ABC. So that's line AC or line AB. All right, that is a line. But if I were to kind of break that line into pieces, I could label it as two separate rays. One of them would be ray BA. Notice stopping at B and going towards A. So it's like this half of the thing. Okay. The other one would be ray BC. Notice it starts as B and goes towards C forever in the other direction, okay? And so if I kind of cut this in half and say, hey, this half is a ray and this half is a ray, together those rays form a line. That means they're opposite rays, okay? And that's it. They start at the same point. They go in opposite directions forever, so they create a line, okay? But notice how meticulous I am about the labeling, all right? One of them has to be ray BA. The other one has to be ray BC, okay? Let's talk about postulates, axioms. We will typically refer to them as postulates. Axioms kind of mean the same thing, but it's basically an accepted statement of fact. All right, we don't need to prove it. We just know that it's true. All right, the second you read it, you're like, yeah, of course that's true. All right. So a postulate, that we have three postulates that we're going to look at here. First is through any 2 points, there's exactly one line, okay? And we kind of know that from algebra. In algebra, how many points do you need to graph a line? 2, all right? 2 points make a line. That's all that's saying, okay? And we've kind of seen that when we draw lines, all right? When you draw lines, you pick 2 points, and then you use your straight edge to draw a line, all right? It's accepted as true. We don't need to prove it. We just look at that and go, yeah, everybody knows that's true, okay? The next one, if 2 distinct lines intersect, their intersection is a point. And again, you already know that from algebra. Remember solving systems of equations? The first way you solved them was by graphing. You would graph the 2 lines, and they would have one point of intersection. That was your solution, okay? When 2 lines cross, they cross at a single point, all right? That's all that postulate is saying. And then the last one, this is the one that's probably new to us. If 2 distinct planes intersect, their intersection is a line, all right? Look around the room that you're sitting in, all right? The wall is a plane. So any wall in that room is a plane. The ceiling is also a plane. So look up at the ceiling. The ceiling's a plane. And when you look at that corner between the wall and the ceiling, how would you describe the shape of that corner? It's a line, all right? And so when 2 planes intersect, it forms a line, okay? So if we look at this, it says, name the intersection of plane ADC and plane BFG, all right? So again, here I have a box, and each side of the box is a plane, all right? Each corner of the box is a line, all right? So each edge, of the box is a line. And then those little points in the corner, those are points, okay? So name the intersection of plane ADC. So let's see, ADC is the top of the box. So we're looking at the top of the box. And plane BFG, so BFG is the side of the box. So look at where those 2 sides come together. They come together right here at this kind of edge. And that edge is a segment, or really in this case, because we said it's a plane, you would have to imagine those extending forever in each direction. This would be line BC, or you could call it line CB. If you said segment BC here, that would also be fine, all right? Again, we don't draw planes as going on forever. We just have to imagine that they go on forever, okay? So imagine each of those sides go on forever. So this is kind of more the correct answer that we're looking for, okay? Visually, yeah, it looks like segment BC, but it's really line BC, all right? And it'll take a while to get used to those kind of little subtle details, all right? Name 2 planes that intersect at BF. So once again, let's find BF. BF is right over here. And so again, there's BF. Which 2 sides of the box come together at BF? Well, it's the front side and this right-hand side. So I just have to label those planes. So I would say, well, that's going to be plane. Let's see, the front one is ABF or something like that. And again, you don't have to use those specific 3 points. You could do AEF or BFE, all right? And plane, again, any 3 points from that plane will do as long as they're not in a line. Oh, so I'll just say BFG. That was the one that I used earlier, BFG. Or you could say GFB or BCG or GCB, all right? We're going to look at one more postulate, and this is that kind of thing that I've mentioned a couple times. When we label a plane, it can't be points that are all in a line together. Through any 3 non-collinear points, there's exactly one plane. And that's why when we label something like a plane, we have to use 3 non-collinear points. We can't use points that are in a line. Because if I have 3 points that are all lined up, there's an infinite number of flat surfaces that can go through that. There's an infinite number of planes that goes through 3 points. Okay, that are collinear. So we need to choose non-collinear points. So through any non-3 collinear points, there's exactly one plane. For example, name the plane that contains points N, P, and Q. And if you've been paying attention, you should probably chuckle at this question and say, well, how about we say that that's going to be plane N, P, Q. All right? And so again, those 3 points are non-collinear. They make a plane, all right? And that same plane can be labeled in other ways. I could do NPR, all right? Or I could do RQP, all right? So any of those points that's on that plane once I have it identified. Name the plane that contains J, M, and Q. Once again, we can take the easy route and say, hey, that's plane J, M, Q. And now that I've identified that J, M, Q, all right, I could maybe figure out another point that's on there. And you might be looking at the picture going, there is no plane there. There's no plane that's drawn there, all right? But remember, we can't technically draw all the planes. Planes have no thickness. When we draw it, we're just drawing a visual representation. There's an infinite number of planes floating around in space that we don't necessarily see or don't necessarily draw. Is there still a plane that goes through those 3 points? Yeah, it would be kind of like the diagonal of the box if I were to kind of draw a visual representation of this thing. It would be this plane right here, kind of in the middle of that box, going right through the center of that thing. And so now you can see even more points that are on that plane, okay? And so just because it's not drawn doesn't mean it doesn't exist, okay? And now name a line that is coplanar with JK and KL. So if I come up here, JK and KL, if I were to erase that extra plane that I've drawn. So JK is right here and KL is right here. I want a plane that has both of those lines on it. Well, it's got to be that top one, okay? So maybe I would label it as JKL or something like that, okay? And again, there's other ways to label that plane. I'm just choosing the representation that I thought was the easiest, okay? And so that's the idea behind points, lines, and planes. Points are a single location, all right? We draw them as dots, but really they have no width, okay? Or height or whatever, all right? Lines extend forever in each direction, all right? And they, again, have no width. We have different pieces of the line, like the segment that has 2 endpoints, the ray that's like half the line, all right? And then we have a plane, which is a flat surface that extends in every direction, all right? And so then we start talking about postulates and theorems, how these things interact, how they connect, what shapes they create when they cross one another, all right?